Hi, how's everyone today? So the plan for the next 20 minutes or so is to go through some of the basics of simplifying expressions in basic algebra. So this comes from chapter 5 in your textbook and parts 4 through 7 of your supplement, also known as the real algebra. Here we go, I hope. All right, so we're going to be taking a look at some of the basics of algebra. Algebra is a tool that's used to analyze a situation when we don't know the exact value of a number or of a quantity or amount. Now, for some of you, this is no big deal. You've done algebra before in high school, maybe you've just graduated, but for others of you, this part of the course may make the difference between your success and your failure in your chosen field. So I'm going to ask you each to be considerate of your classmates, both those that may find this to be a review and those that may need extra assistance with this. Be sure you ask questions if there's something that you need a little bit more time to process or that you need to dwell on a bit to understand. All right, there's some definitions here that we want to make sure everyone is clear on as we begin. The first of those definitions is that of a variable. A variable is defined as an unknown quantity. The variable tends to be a letter. It stands in for a number. In other words, if we don't know how many shoes to order for our new business, we might just put in the letter S for shoes, as in S is the number of pairs of shoes that we ordered. S is thus the variable. A constant is the second word we want to talk about. A constant is just what it is. It is a number without a variable. The value of 7 is constant. The value of 7 is 7. It never changes. 7 is not suddenly worth 6.5 or 0. The value of 7 is constant. So 7 is a constant. Coefficients are multipliers of a variable. So if I've ordered 6 new tables and they're $40 each, then it would be 40 times 6. 40 would be considered the coefficient or the multiplier of the number of tables. The coefficient is a number. The hard part here is that both coefficient and constant start with C, so sometimes people mix up those two words. Coefficients have variables, constants do not. Constants cannot vary, so they do not get a variable. That's how I always kind of plugged it into my brain, but coefficients are multipliers. They have to have a variable to multiply by. A term is any combination of coefficients and variables. So 2x would be a term. X alone would be a term. 2 alone would be a term. So you can mix up the letters and numbers together to make a term, or a variable alone could be a term, or a number alone could be a term. Thus, any combination of coefficients and variables. All right. The second thing we want to pay attention to is whether or not we're looking at an expression or an equation. As you look at these 6 sort of different colors here, can you tell me which ones of these 6 would be expressions? As we look at this one, this 5x plus 10 would indeed be an expression. 5x plus 10 equals 0. This is an equation. 5 minus 3x plus t, this is an expression. 2 times the quantity 3x plus 8 minus 7, this is another expression. This yellow one, 15, is equal to 5 times the quantity 2x plus 1. this is an equation. X minus 5 equals 3. This is another equation. All of these equations, notice they all have an equal sign in the actual problem. The expressions do not. It's also interesting to note here that when you're dealing with an expression, expressions are evaluated. We talked about that yesterday or in the last one, evaluated. Expressions can be evaluated. However, equations are solved. Whoops. There we go. Solved. S-O-L-V-E-D. Equations are solved. All right, let's see how this is going to go. I just don't know. Okay, so the next thing we want to talk about are like terms. Like terms are terms where the variables are exactly the same and they are to the same power. So we have some examples here. If we look at 2a squared, is there amongst our other sets another a squared? Well, we've got the 2/3 a squared b and the minus 5a squared. What's interesting here is that this one, the minus 5a squared, these are like terms. These two are like terms. The a is the same in both. The power squared is the same in both. Because they are both a squared, we look only at the variables. The coefficients of 2 and negative 5 are ignored. We don't pay any attention to those. If we look at some of our other numbers, here we have a 2/3 a squared b. Now, in order to find a like term to this, we ignore the fraction. That doesn't matter. We need both an a squared and a b. And since there are no more a squared b's, this one does not have a like term. So there's nothing wrong with the term that it is. It just is not going to have a like term. If we look at 15 squared b, I'm sorry, there's not a squared there. 15/7 b, is there another term that has a variable of just a b, or b to the first, if you'd rather? And as you look at this would not be a like term. It's an a squared. This one is an a squared and a b. I need just a b, so this is not like. Since the 2a squared wasn't like, the minus 5a squared would not be. I'm looking for just a b, and I have that right here with the 3b. So these two are also like terms. All right. We use like terms to combine or simplify our problems. Here I have 4x plus 2 minus 7x. So this 4x is a like term with the minus 7x. You will always take the sign in front. So if I do 4x minus 7x, that's going to give me a negative 3x. And that plus 2 doesn't have a like, so I'm just going to bring it down with a plus 2. Now, I cannot combine my 2 without a variable to my negative 3x. So I'm just going to leave this as it is. And this is indeed done. That is all the simplifying I can do. Notice I'm not telling you what the x is worth. I am not going in and saying what x equals because I don't know. It will differ depending upon what that value of x is. If x is 5, I'm going to get a different answer than if x is a negative 1. I cannot give an answer when I'm combining like terms other than a simplification. All right, let's take a look at 7 minus m plus 4 plus 5m. Looking at the 7, this is a constant term. It does not have a variable. So I'm going to look for another number that does not have a variable on it, and that's going to be the 4. So I can combine the 7 plus 4, and that's going to give me 11. With my remaining terms, I have a minus m. Now, it's worth noting that this would be a minus 1m. If there's no number in front, we can put a 1 there, and that would be like with the plus 5m. So I have a minus 1m plus 5m. And when I combine those, that's going to be 11 plus minus 1 plus 5 is 4m. This 11 does not have an m on it, the 4m does, so I cannot combine those any further, and I'm left with 11 plus 4m being my simplification and my answer. The third example. The third example is decimals. There's absolutely nothing wrong with that. You can have decimals, and as a matter of fact, you're in business, so you will probably have mainly decimals that you're going on with here. So decimals is what we're looking for. Same process as before. I don't want the blue ink. Okay. I'm going to take my 14, and I'm going to add that to my minus 5.6. Both of these, again, are constant terms. They do not have a variable with them. So I'm going to do 14 minus 5.6. And I'm going to go ahead and do that on my calculator. And if I do 14 minus 5.6, I'm going to get 8.4. Once I've used these terms, I don't need them again. Some of you will find it helpful to put like a light line through them. That's fine. But find some way to indicate to yourself that you've used them. That way it doesn't get too much like alphabet soup. All right, so then I'm going to do a minus 3.2y, and I'm going to add 1.3y. Again, these are like terms because they each have a y in them. So I can use my calculator to do a minus 3.2 plus 1.3. And when I do minus 3.2 plus 1.3, I'm going to get a minus 1.9y. Right? Or that doesn't look so nice, so we're going to do 1.9y. All right, and again, I can't combine those because this one has a y, the 1.9 has a y, and the 8.4 does not. So that's it, and I am done with this problem as well. That's as far as I can simplify it. Until I know what the value of y is, I can't do anything more with that problem. And then I saved the best for last. This one is fractions. Again, I have a 1/5 w minus 8 plus a 2/3 w. My recommendation on this is that you do go ahead and use a calculator, particularly a calculator with a fraction button. That is absolutely possible. It's a recommended calculator for this class has a fraction button on it, so that should be possible. But if you need some help with that, don't hesitate to reach out to Tim or I. You can also do this by hand. You have 1/5 w plus the 2/3 w minus 8. And I'm just rearranging these. The 1/5 and the 2/3 could use a common denominator of 15. So that's going to give me a 3/15 w plus a 10/15 w. Or a 13/15 w minus 8. I cannot combine the 8 with the 13/15 W because the 8 is a constant and the 13/15 W is a variable term. So I cannot combine the W without a W. Fantastic. Okay. You weren't supposed to. Sorry, my Siri's talking to me. All right. The next thing we want to go over are a few of the properties. A few of the properties that we need you to recognize are the commutative property, the associative property, and the distributive property. Quick and painless, commutative property is about the way the numbers move. And basically the commutative property says if you're doing addition, then when you add 2 plus 3, you get the same answer as if you were to add 3 plus 2. If you're doing multiplication, if you multiply 5 times 7, you get the same answer as if you were to multiply 7 times 5. This is the commutative property. It says that the numbers can switch order, they can move positions, and your answer will still be the same. This happens with addition and it happens with multiplication. It does not happen with subtraction. It does not happen with division. If we look at the associative property says you can change groups, just like your associates for school are different than your associates at home. Maybe you have 2 homes. Maybe you don't associate with the same people now in college that you did in high school. Maybe you do. But associative property is about the grouping symbols and the way that you group things. So you'll see you have 2 plus the quantity 9 plus 3, that this is equal to the quantity 2 plus 9 plus 3. Notice that the order of the numbers did not change. I have 2 as my first number, 9 is my second number, and 3 is my third number. On the other side of the equal sign, I still have 2 as my first number, 9 is my second number, and 3 is my third number. The order of these numbers did not change. What did change is the way that I grouped them. That 9 plus 3 is a different grouping than 2 plus 9. But the equation is the same. If I add the 9 and 3 first, I get 12 plus 2 is 14. Versus the other side, or if I add the 2 and 9 first, I get 11 plus 3, and it's still 14. So this says, as long as you're just using addition, you can group the numbers any way you want. Likewise, as long as you're just using multiplication, you can group the numbers any way you want, right? The last property we want to deal with is distributive property, and you've probably done this a lot. The distributive property is about distributing multiplication across addition or subtraction. So here you see an example where we have 5 times the quantity 2 plus x. This is the same as taking 5 times 2, which is 10, and adding it to 5 times x, which is 5x. You can do distributive property also with fractions. So here I have 2/5 times 5x and 2/5 times 30. Now, you can do the multiplication longhand with a fraction, but it may be in your best interest to get a tool that does it for you, such as a calculator. If you do not have a calculator that does fractions, you may want to consider getting one. All right, let's do some examples here. Our first example for distribution is 3 times the quantity 4x minus 5. So what we're going to do is we're going to do 3 times 4x and then we're going to subtract 3 times 5. We can simplify each piece of this. 3 times 4x is 12x, minus 3 times 5, which is 15. This leaves us with 12x minus 15. I cannot add the x to the constant. I cannot add the variable term to the constant term. So this is it, and I have completed this problem, simplifying it as much as I can. I've included this one in here, this minus, and then in parentheses 2x minus 3, because we need to think of this minus as a negative 1 times 2x minus 3. That would give us a negative 1 times 2x, which is going to be a negative 2x, minus a negative 1 times 3. So I've got a minus 3. And you remember the minus is a plus. So that gives me a negative 2x plus 3. I cannot add them together because one is a constant term and one is a variable term. They are not alike. So minus 2x plus 3 is my final answer here. In the third example, I've got some decimals added all over again. So we're going to run through this one. I've got a negative 2.4 times 6x. And I'm going to pull up my calculator because I don't know that one by heart. I mean, I think I have an idea. But just to be sure, so I don't make a mistake, I'm going to do a negative 2.4 times 6. And that's going to give me a negative 14.4. And I'm not going to forget that x there. Then I'm going to have a minus 2.4, negative 2.4 times 1.5. And that's going to give me a negative 3.6y. I did that one out. Then I'm going to do a negative 2.4 times 8. Because this parentheses had 3 different terms in it, I need to multiply by all those terms. Negative 2.4 times 8 is a negative 19.2. And now I'm going to check all my signs. So I'm going to have a negative 14.4x minus a minus is a plus 3.6y. Plus a minus is a minus 19.2. I cannot combine x's with y's because they're different letters. And this last term is a constant, so it does not get any at all. So I can't combine it with any of the letters. So this is it. This is all I can do. That's the best I can do to clean it up. So when I multiply or distribute that negative 2.4, I end up with a negative 14.4x plus 3.6y minus 19.2. Okay, just trying to make those dots good. All right, here we have a last example. This one is fractions. So how do we do fractions? Well, just the same way we would, and we hope this would be 2/5 times 5x. I'm going to write it out to make it a little bit more helpful. Minus 2/5 times 5/3. All right. So the trick to this one, I say trick, maybe not a trick so much, but can you think of this as 5x over 1? Sure, that at least makes it a fraction and puts it in a form that might be helpful. Now I can see that I have multiplication here and that the 5 and the 5 are going to cancel out. That's going to leave me with just a 2 times x over 1, or just a 2x. Now, when I look at the second part of this, I see again that what I have is a 5 and a 5, that those will cancel out. And I'm left with 2 over 3. Oops, different color blue, but that's okay. So I have 2x minus 2/3. This is a variable. This one is a constant. They are not like terms. I cannot combine them. So this is it, folks. This is all we can do. And we have simplified the distribution as far as we can. All right, as you might have imagined, we're now going to take these and put it all together. So here's what we got. We're going to simplify some expressions. The first expression we're going to simplify is a negative 2x minus 4 times the quantity x plus 7. All right, so let me get this done here. Ink color, I want the blue. All right, we got blue. So this is going to give me a negative 2x. I'm going to distribute the negative 4. I'm going to take the negative in front of it. So I'm going to have a negative 4x minus 4 times 7, or I'm going to have plus. Negative 4 times 7 is a negative 28. So this gives me a negative 2x minus 4x minus 28. Is there anything we can combine? Certainly. Minus 2x minus 4x are like terms. So this is going to give us a negative 6x minus 28. This has an x. This one does not. I can combine no more. So that's it. And we can put a red box around this one because we are done. What do we do when there's two sets of parentheses? We just do them one at a time. So again, I'm going to go back with the blue color here. Distributing the 3, I'm going to have 3x plus 15. That's 3 times x and 3 times 5. I'm going to write this as a minus 1 so that when I distribute that, I have a minus 2x plus a minus 9. Combining like terms, I have a 3x with a minus 2x. That's going to be an x. And I have a 15 plus a negative 9. So that's going to be a 6. I cannot combine any further. I cannot add a 6 to an x. So x plus 6 is it. And that is all that she wrote. Gotta go to the next one. Here we go. All right. So the next one, well, it looks like this one went a little hog wild. Okay, so we'll drop down. That's all right. This one is a little bit more intense, but like before, we want to start out from the inside out. So I'm not going to bother with this right now. 5a minus 1 plus 2, 6, and I'm going to work from the inside out here. So this is going to be plus 6a plus 8. Now I can distribute the 5. So I'm going to have 5a minus 5 plus, and I'm going to distribute that 2 inside the square brackets, plus 12 plus 12a plus 16. Now I can combine all my like terms. I got a 5a, I've got a plus 12a, that should be 17a. I got a minus 5 plus 12 plus 16, that should give me a plus 23. All right, I just want to check my work here. So I mean, 2 times 3 is 6, 2 times 4 is 8. I could have combined these two if I'd wanted to do the 6 and the 18, 6 plus 8 to get 14, but I didn't have to. The square brackets, for those who do not know, are just a visual cue in order to differentiate from the round brackets, because otherwise it gets too confusing. So the square brackets don't mean anything different than regular parentheses. It's just a visual break to try and differentiate. So this 2 is just going to be distributed into each one of those 3 terms, just as if it was parentheses. And this 5a minus 1 needs to be distributed as well. And then when I combined, yep, it looks good. You guys let me know if I'm missing something. I think I'm all right. But I can't add a's to not a's, so this is it. And I have 17a plus 23. And then I should have one more example. There we go. That one's got a fraction in it. So I'm going to be sure to do that one. All right. So I've got parentheses. Again, I need to work from the inside out. I can't add the x on 6x. I can't add 6x plus 12. Those are not like terms. But I can distribute the 1/6. All right, so that -3 I'm going to leave. Square bracket, same as a parentheses, 9 minus 1/6 times 6x minus or plus -1/6 times 12. So that's going to be a -1/6 times 12. Okay, so I'm going to use my calculator, which is fine. 9 minus 1/6 of 6x. The 6's will cancel, and that's just going to give me a minus x. And then I have plus a -1/6 times 12, so that the 6 and the 12 will cancel, leaving me with 2. So that's just going to be plus a -2. I can distribute the -3 inside, or I can clean up the inside, whichever you would prefer. I'm just going to go ahead and distribute because I want to. Doesn't make a difference. So I'm going to have a -27. -3 times a -x is going to be a positive 3x. -3 times a -2 is going to be a plus 6. I can still combine this -27 with this positive 6, getting a -21 plus 3x. Now I don't have anything more I can combine. I can red box this guy and be done. There. Okay, that's about the level that you're expected to be able to participate in this at. If you have further questions on this, please contact your instructor, which is me, or your math support person, or the Math Center. We are all here to help. Your graded assignment for this particular section is on WebAssign, and it's called Simplifying Expressions. Thanks.